Hello, welcome. Today we're going to talk a little bit about bits to antenna and back. Analog Devices is the broadest line RF semiconductor company in the world. We cover the converters and we also cover the RF section and op amps as well. Today we'll start off by talking about a new part. This is a part that we introduced about a month ago. It is the ADL5324. It's a half-watt driver amp, and it's the only half-watt in the industry which is able to go to 105 degrees C. A lot of driver amps, when you have the high-power amplifier, it usually generates a lot of heat. It's one of the major concerns, especially military systems and other systems that use higher power amplifiers, is the heat and how to get that out and reliability of components. This part we have spec'd up to 105 degrees C to be able to take care of some of those problems. It also has the ability to run off of 3.3 volts and actually anywhere between 3.3 volts and 5 volts operation. Now the performance as far as the linearity will go down a little bit at 3.3 volts. However, the gain stays flat. So the ability to be able to adjust your LDO from 5 volts down to say 3.3 volts gives you some flexibility as far as power consumption and the use of that in the part. So an idea would be to take a power detector, determine how much power you have going into the part, see whether you need the full linearity of the part, and be able to adjust your LDO based on the power you have going in to be able to save power in this case. This shows you the performance at 5 volts as compared to 3.3 volts at specifically around 2.14 gigahertz. So you can see that there is a difference in the performance, but again the gain stays flat. Here you have P1dB and up here you have the output IP3. Another part that we've announced at the show is the ADF4159. This is a 13 gigahertz PLL. It's an integer end PLL. One of the keys behind this is a very high PFD frequency. It has 110 megahertz PFD frequency, which allows you to be able to get very good phase noise. The nominalized phase noise of minus 222 dBc per hertz, along with the high PFD frequency, allows you to be able to get very good performance. This part is also interesting because you can also do things like FSK and PSK type modulation, as well as different ramp forms like parabolic or different sweep things, including delay modes. So it's very good for radar type applications or where you need to basically sweep very quickly over frequency. This part is able to do those things. So what is the ADF4159? And I've went over many of these things. First of all, you can get sub-hertz resolution. It has a 25 fixed bit modulus. Your max PFD frequency is again 110 megahertz. You can program ramps included in it. You can do triangular and sawtooth waveforms. And it is very, very low power. So you can use this in some places where you could use a DDS for very low power. Another part that we've introduced at the show is the AD9914 and 9915. This is the highest performance, highest frequency DDS in the industry currently. It has a 32-bit programmable modulus. You can also clock this up to 3.5 gigahertz in the case of the 9914 and 2.5 gigahertz in the 9915. Besides the higher sampling rate, it also has better spurious-free dynamic range than the high-speed DDSs that are currently in the market. This gives you an idea of the spurious-free dynamic range at 1.47 gigahertz. And this gives you an idea of the phase noise. The phase noise on this part is also better than some of our previous versions as well. even though the sampling rate is much higher. It's over 3 times higher than what we've done in the past. We're also showing and demonstrating our circuits from the lab. As I had mentioned before, Analog Devices is the broadest line RF semiconductor company in the world. So we have all the bits, and what we've been doing is we've been concentrating on connecting those bits together and showing you how to do that. So we have eval boards, we have layouts, we show you how to connect parts together that would naturally flow together. An example of that is we have a PLL VCO that we've mixed with a very low power LDO, and you can see the difference between a very, very low power LDO as compared to something, or a very, very low noise LDO as compared to an LDO that has a little bit more noise on it. You can see the difference that it makes in a PLL VCO type chip. So those are some applications where we've shown circuits from the lab. And then we also have circuits from the lab that integrate modulator with a DAC and all sorts of integration levels where we show you how to connect those parts together. What is the circuits for the lab? It's engineered by ADI experts to be able to take care of some of those challenges that you run into when you connect parts together. It basically reduces risk for you when you try to be able to put your system together. And we give you the hardware, we give you the design files, we give you everything you need to be able to do that. The way you get into circuits from the lab is if you go to a specific part and you find a part on the web you like, there will be a reference for what circuits for the lab are available for that particular product. We also advertise them on the Richardson website as well. One of the circuits from the lab that we're demonstrating at our booth is basically it is an IQ modulator that includes a PLL VCO, and we've included a DAC interfacing to that part, as well as a clock circuit as well. So this gives you an idea of some of the integration that you can get and some of the things that we've done with circuits from the lab. By the way, I'm happy to take any questions that you have. This gives you an idea of the modulator PLL VCO. It is the ADRF 6702 that we're showing at our booth currently, which belongs to the circuit from the lab. But this is a IQ modulator with a very high performance PLL VCO. Another thing that we're highlighting is Analog Devices' ability to be able to use the JESD 204 ADC and DAC interfaces. This is a new standard, a relatively new standard. The JESD 204, what it does is it simplifies your interface between your DACs and ADCs and your FPGAs. It's becoming it is an industry standard that is increasing in popularity. Basically, it allows you to be able to go from many different lines going between the FPGA and the ADC or DAC converter, and allows you to replace that with 2 lines or 4 lines or however many you need depending on the speed of the ADC and the DAC. Previously, your bottleneck in going higher and higher in your sampling rates of both your ADCs and DACs has been that interface between those parts and the FPGA. So that problem has been solved with this new JESD 204 interface. Now the JESD 204 allows up to speeds up to 3.125 gigabits per second. JESD 204A adds multiple serial lanes where you can do multiple of those. And then you have JESD 204B, which allows converter speeds up to, the interface speeds up to 12.5 gigabits per second. And those are the standards that are out currently. So actually, yes, in a way, what you have is the lines actually work by themselves independently. So they have their own clock And basically, you're able to just take that pipeline, and in the end, it meshes those pipelines together, but they work independently. So if you have one group, it's not dependent on the performance of the other group. In the end, they have their own clocks, and they mesh them together in the end. These are some of the parts that Analog Devices offers currently with the JESD 204 and 204A type interfaces, the AD9639, the 9644, and the 9641. We've introduced a new one to the market just at the show here today, and that's AD9128. This is a 16-bit DAC. It runs at 1.25 gigasamples per second. It's meant for communications type applications. It has a 32-bit NCO. Has the ability to be able to do offsets in both phase and magnitude for interfacing to IQ modulators. But this is something, really the key behind this part is the JESD 204A serial interface. And it's our first 16-bit 125 gigasamples per second part that has this interface. And that's what I have for you today. Analog Devices does cover that whole range, and we welcome you to come over to our booth to be able to see some of our presentations that we have showing you some of these, and we can go into more detail there as to some of the things that we have available. Any other questions? Oh, great. Thank you very much.